Hello all. I'm going to tell you a little bit more about my project Cranberry Fields, a project where food, people and water come together and form a whole. This project came about by combining my fascination and the drought problems on the Campine Plateau. Everything started with my fascination. I was born in Moos Hasmego, known for its large share of fruit farming. My grandparents were also fruit farmers, and this company is currently in the hands of my cousins. This is how my fascination for fruit cultivation started. This project is located at the lowest point of the Campine Plateau, but also, very importantly, at the highest point of the Weyers. This has a major impact on the water problems and the story I am going to tell you. When we zoom in on the location, we can clearly see on the Ferraris map a large proportion of the headland in the area. Also, many fens around the rivers are very important. And thirdly, agriculture around the farms is also visible, but to a lesser extent. If we look at the present, we see that the watercourses are still present, but that the lakes are less predominant, and when we zoom out and look at the scale of the Weyers, we see that a part of the source of the Weyers is located here. On the elevation map, there are clear veins visible that are lower and contains the rivers and fens. The elevations vary from 62.5 meters to 80 meters above sea level. On the highest area today, the city, districts and industry are located. The Campine Plateau is known for its sandy soil. This soil has a low pH value, which also means that it is acidic. This explains why there is no agriculture in the area anymore. It's not fertile ground. When we look at the current vegetation and land use of the area, we see that there are still fens present where the seepage water is. On the other hand, headland is present in the natural areas, but on the higher areas we see a lot of forest and pavement. This is therefore very problematic for the Weyers. Because of this paving and forestation, only a little bit of infiltration is possible, so the water cannot seep into the ground but is immediately led to the watercourses and disappear. As a result, the source of the Weyers starts to dry out and will disappear. From this, I started looking at how fruit cultivation could offer a solution, and I ended up with cranberry cultivation. This type of fruit needs very specific cultivation, and as you can see here, among other things, it needs water for the harvest and an acidic, sandy soil. The fields that are ready for harvest are flooded. This causes the cranberries to flow to the surface. Next, people use a beater to loosen the cranberries from the plant. This allows the cranberries to grow to one side of the field and pumped out of the water. When we look at the water needs for growing cranberries, we see that there is a lot of need for water, especially in the winter months due to the harvesting and the frost. If we take into account the rainwater of the field, a total of 2.50 cubic meters of water is needed for 1 square meters of cranberries, spread over a whole year. The available water consists on the one hand of the wastewater coming from the neighborhoods and industry. Per person we produce 120 liters per day. Of this, 84% is purified in Belgium. When this is purified, it cannot be used as drinking water. There is also the rainwater from the neighborhoods and industry. A part of it can be reused by the inhabitants. The other part can also be collected. Here you can see a calculation of the available rainwater. So my idea is to use cranberries as a transition between the city and nature to infiltrate water into the higher areas. This as a solution to the dehydration of the source of the Weyers. Here I want to use a system of drain, purify, buffer, transport, and infiltrate. So I have designed a circular system so the environment can benefit as much as possible. It consists of water purification, energy production, cranberries, and very important water infiltration. Each element affects the others. When we zoom in on a part of Hotel Oost, we can collect the available water from a part of the neighborhood and the street. And as you can see, there is enough water available for the cultivation of cranberries. When we start listing all these elements, we get an overview as a program for this project. On one side there is room for storage and production of cranberries, resettlement of water, water purification, bioenergy, and water buffering. But there is also place for the transport of the water to the fields, the cranberry fields themselves that take care of the infiltration of the water, the bees and the bumblebees that take care of the pollination, and the infiltrated water then returns to the surface at the weirs as seepage water. I would like to conclude with this image showing the view of the cranberry fields as a transition landscape to the nature, where people can meet each other and they can come to rest.